Hi guys, welcome to a new episode of our podcast called Live on Mars. As you know, we are Natalia and Farah. Now, in chapter 2, we're going to discuss how climate change and natural resources can be a problem to colonize Mars. I give the floor to Natalia.
Thanks, Farah. First of all, we have to know a good definition of what climate change is, and I'll define that as a change in the average conditions, such as temperature and rainfall in a region over a long period of time. NASA scientists have observed Earth's surface is warming, and many of the warmest years on the record have happened in the past 20 years.
That's right, climate change is something that is happening a long time ago, and we need to fix that before going to invade another planet. Besides, I listen that many people confuse weather and climate, which is very different. So that's why I'm going to talk about local weather vs global climate. The weather describes the condition outside right now in a specific place. For example, if you see that it's raining outside right now, that's a way to describe today's weather. Rain, snow, wind, hurricanes, tornadoes are all weather events. On the other hand, climate is more than just one or two rainy days. Climate describes the weather conditions that are expected in a region at a particular time of year, such as temperature and rainfall in a region over a long period of time. For example, 20,000 years ago, much of the United States covered in glaciers. In the United States today, we have a warmer climate and fewer glaciers.
You already explained to us very well the difference. Now I'll tell a couple of examples so we can understand more. So, 1 or 2 weeks of rainy weather wouldn't change the fact that Phoenix typically has a dry desert climate. Even though it's raining right now, we still expect Phoenix to be dry because that's what is usually the case. Returning to the topic of climate change, I'll tell you the effects of Earth's warming, such as rising sea levels, shrinking mountain glaciers, ice melting at a faster rate than usual in Greenland, Antarctica, and the Arctic, and change in flower and a plant blooming times.
There's a lot of effects that tell us why when you have a climate change or just change of weather. As you can see, the climate change is a lot bigger than just rainy or sunny days. Also, science a lot of time the human has seen use their resources in a sustainability way. That is why climate change appears. But which are the real causes of this? Scientists say that the principal reason is the greenhouse effect. Since the middle of 20th century, the human expansion of the greenhouse effect, warming that results when atmosphere traps heat radiation from Earth toward space. Natalia will explain this effect more.
Certain gases in the atmosphere block heat from escaping. Long-lived gases that remain semi-permanently in the atmosphere and do not respond physically or chemically to change in the temperature are described as forcing climate change. Gases such as water vapor, which responsibly physically or chemically to change in the temperature, are seen as feedbacks.
These elements from the greenhouse gases, and now I'll explain the water vapor and carbon dioxide. Water vapor, the most abundant greenhouse gas, but importantly, it acts feedback to the climate. Water vapor increases that Earth's atmosphere warms, but so does the possibility of clouds and precipitation, making this some of the most important feedback mechanisms to the greenhouse effect. And the carbon dioxide, a minor but very important component of the atmosphere. Carbon dioxide is released through a natural process such as respiration and volcano eruptions, and through human activities such as deforestation, land use, chases, and burning fossil fuels. Humans have increased atmospheric CO2 concentration by 48% since the Industrial Revolution began. This is the most important log-life forcing of climate change.
Gases that contribute to the greenhouse effect include nitrous dioxide, water vapor, carbon dioxide, and methane. And the last elements are methane and nitrous oxide. Methane, hydrocarbon gas, is produced both through natural sources and human activities, including the decomposition of wastes in landfills, agriculture, and especially rice cultivation, as well as rumen digestion and manure management associated with domestic livestock. On a molecule-for-molecule basis, methane is a far from for active greenhouse gas than carbon dioxide, but also one which is much less abundant in the atmosphere. And nitrous oxide, a powerful greenhouse gas produced by soil cultivation practice, especially the use of commercial and organic fertilizers, fossil fuel combustion, nitrate and acid production, and biomass burning.
After listening to every element and how contribute to the greenhouse effect, we can see that bad management of our resources is a true cause of why the greenhouse effect from and why climate change appears. That make us reflect about if the nature offers of multiplied resources that we can use to our own benefit to innovate technology, economy, and the production. What we are using our resources in a negative way, human is overexploiting nature, and this is resources finish because they are going to finish at the same point. We couldn't innovate more for the future, so it's better to take care of what we have now and then can innovate more and make more economy. But let's protect our environment, our home. Human only thinks money, money and money.
I couldn't be more agree with you. The humans have to protect the earth because we are at the point where we need to look life in another planet because of our bad management of resources, as you already say, and actions towards nature. We are not thinking about the future and what is going to happen. So, how do we link this to create a colony on Mars? Well, I have the answer. Man, to extreme actions such as illegal logging, illegal fishing, illegal mining. When I say illegal, it is because there's a certain limit on fishing, logging, and mining. Since we have these resources to use it, and it's fine because if we did not use them, it will also open other consequences like overpopulating fish, etc. However, the human being is abusing them since a long time ago, and that's not the idea of using the resources that we got.
These actions later make big problems for the environment, like cause a big climate change, and think how humans will do it on Mars, how humans will use the limited resources and they find there. We will continue doing the same. We will perform the same actions as always. Or we are going to make a change. NASA has to think about a lot of it because the same thing cannot happen. Humanity has already done enough negative things on the earth. Humanity already contaminated, neglect, and overexploit earth. Cannot be the same on a planet new like Mars. And that's why we want to communicate and make understand on this podcast. Before creating a colony in Mars, we have to solve problems here on the earth. It doesn't mean that we not agree to this project because we are supporting the One Mars project. However, we have to make aware people about how we are using our resources here on the earth and how it's linked to create a colony on Mars, the red planet.
Even a Mars colony will need a huge investment of supply ships to keep settlers alive in a toxic, freezing Martian environment, but the numerous abandoned bases in Antarctica show that building cities in less hazardous places on Earth is difficult enough. Advocates of a colony to the potential to mine water and rare minerals on the red planet, but searching for resources or avoiding a potential asteroid strike on Earth are not immediate enough motivations to inspire a Mars settlement, says Andy Weir, author of The Martian, which depicts an astronaut stranded on Mars. And now we're going to talk about conversations that astrologers have had about this project of going to Mars and how this could benefit the Earth.
I don't believe there will be a permanent settlement on Mars. or the moon or anything else of it until there's an economic reason for it. Wade says, whatever its problems are, it's considerably easier to fix the Earth than it colonize Mars. This strategy has kept sustained by limiting human presence there. There is escaping the waiting to go to Mars and start anew, Lee says, of the appeal of colonization. The issue with that particular anxiety comes to this. To go to what? Do we need an entire infrastructure set up in advance to support people there? They say in a conversation.
Missions to Mars don't need to result in colonization to improve humanity's chances of survival, says Robert Zubrin, president of the non-profit Mars Society, which advocates for research to explore and study the red planet. The Mars Society is training people at research stations in the Canadian Arctic and the Utah Desert to simulate life on Mars. And a culture which is going to Mars is going to be much more adept at futuring its prospers on Earth, Zubrin says.
Even exploring on Mars can help us to combat climate change here on the Earth. Let me tell you, the surface on Mars is a cold desert. Scars in landscape point to a history flowing rivers, standing lakes, and possibly even planetary oceans. Yet the current Martian atmosphere has a density that's around 0.6% of Earth, making it far to support liquid water of life on the barren surface.
At some point in the planet's history, however, there must have been a thicker, denser atmosphere, probably dominated by carbon dioxide. And working out what happened to all the CO2 could help us to deal with the increasing amount of gas in our own atmosphere, which is pushing us towards dangerous climate change.
So where did the Martian atmosphere go? A large amount was lost to space, stripped away by the solar wind. Some has been stored as CO2, ice at the poles, where it remains today. But part of the atmosphere was transformed into carbonate, minerals, and preserved through the millennium. Using a combination of satellites and rovers, as well as evidence from meteorites that had been ejected from Mars and landed on Earth, we are beginning to understand how this process of minerals carbonation can change an entire planet's atmosphere.
Humanity has actually become very good at capturing CO2 from the atmosphere through a wide variety of techniques. Once captured, the CO2 is usually compressed into dense liquid. The problem comes in storing the liquid safely and stably. Over millions of years, one exciting new development is called mineral carbon sequestration. This is the process of transforming CO2 gas into a stable mineral called carbonate.
So, how CO2 gas becomes to a solid rock? If CO2 gas is dissolved in the water, it produces a weak acid called carbonic acid. When this acid fluid comes into contact with rocks, known as the basalt and peridolites, which contain a lot of minerals, olivine and pyroxene, they release charged particles of elements such as magnesium, iron, and calcium into the fluid.
More chemical reactions between the rocks and carbonic fluid produce the solid carbon-rich mineral carbonate, which fills cracks and pores space in the rocks. The carbon goes from being an atmospheric gas to mineral deposit. During this process of alteration, the original rock minerals absorb huge amounts of water into their structure. This hydration causes the rocks to expand and crack, exposing fresh rocks that can also react with the water.
This process of mineral carbon sequestration happens naturally on Earth, particularly in ophiolites, piles of oceanic crust that have been transported and pushed up onto continental plates. The natural reaction proceeds very slowly, over hundreds of thousands of years, and the carbon extracted from the atmosphere is an important sink for carbon ejected by volcanic eruptions.
Now, after this introduction about the principal topic, let's talk about how colonizing Mars can improve climate change. here on Earth and in there. For example, let's talk about Earth's natural resources, more specific plants and its fruits. According to a recent project by a class of astrobiology, students and their professors, the students try growing a variety of vegetables in simulated Martian soil to discover which edible species may be prosper for future colonists. There, they confirm that carrots, lettuce, sweet potato, onions, and hops can be grown on Martian soil.
This study was related with vegetables chosen by the students, based on their favorite vegetables. That can confirm the possibility to have vegetables that will be more likely to be selected by the colonists. But that's not the same story with trees. Growing a tree on the Mars will certainly fail with the time, and animals can live there too. Mars has an atmospheric pressure on it at the sea level. Mars only has 0.1 oxygen. That was our chapter 2 about our podcast called Living Mars. Thanks.